Okay, we'll get started. Let me upload today's lecture to CCLE, the draft version, and as usual, often I make updates to the lecture as I'm lecturing. So just be prepared for that. Okay, so that's there. We'll open it. And we'll begin. Put this corner over here. We'll finish knitting this. Okay, so today we'll talk about subsetting, and on Friday we left off. We talked about subsetting atomic vectors, and we said you can just give it some integers of the kind of the positions that you want, or you can give it negative integers of the positions you don't want, and you can give it a logical vector, true, false, and it will only return the values where it's true. And if the vector is named, you can give it a character vector. Okay, so I hope all of this is familiar and okay. Let's talk about subsetting lists, and this is very important. Okay, so subsetting a list works kind of the same way as subsetting an atomic vector, but we have two kind of subsetting operators. We've got the single square bracket, and we have the double square bracket or dollar sign. Okay, the single square bracket will always return a list. So if you subset a list, it returns just a portion of the list, but it's still a list. Okay, if you want the contents of some list, one of the list elements, then you'll use the double square bracket. Okay, oops, so this is a typo. It should say the subsetting operators, not there, but the subsetting operators, double square bracket and dollar sign, are similar to single square bracket, except it can only return a single object, and it allows you to pull the pieces out of a list. Okay, the dollar sign's kind of a shorthand for the double square bracket if you've got if your list elements are named. Okay, and it's important to remember that the single square bracket always returns a list. Okay, so you can think of if you have a list called X, think of it as a train. Okay, you've got train, and each car carries different objects, and so X double square bracket 5 is the object, the stuff that's inside train car 5. Okay, whereas X4:6 single square bracket is kind of a smaller train with cars 4, 5, and 6. All right, and if you just do X single square bracket 5, it'll give you the train car 5. Okay, it still counts as a train, or it still counts as a list. Okay, if you want what's inside the car, you've got to use double square bracket. Okay, so because double square bracket gives you what's inside a train or inside a car, it can only return one object, right? It can only return one thing. So you can only give it either a single positive integer or a string. So here, A is going to be a list with X of basically 2 train cars. It's a list of 2 elements. X is 1 through 4, and Y is the numbers 9 through 6. Okay, so A double square bracket 1 gives you the object inside, which is the vector, and A double square bracket Y will give you the object inside train car Y, which is the vector. Okay, and you can this got cut off, but you can use a single square bracket. Here, let me magnify this. Okay. So if I run this, it returns those things. And if I do a single square bracket, y and x, it will return a list with basically train y and train x, train car y and train car x. Whereas if I do double square bracket with y and x, it says you can't do that, okay? It gives you an error. Here I've got list D, which has A, B, and C, 3 elements. It's a list of 3. A double vector, B is logical, and C is character. And if I do D single square bracket 1, it gives me back a list of A, and it's got 1, 2, 3 inside of it. Is that okay? And if I, so I'll run this, and then, but if I want, oops, double square bracket 1, that will give me the vector 1, 2, 3, okay? So maybe just keep adding more stuff here. So type of, what will type of D single square bracket 1 return? It'll say list, right? Okay. And type of D double square bracket 1 will return what? Type double, right? So this is the list, this is the vector. Okay, here's a few more examples. So here I've created a list of 3 things. L1 is going to be a list of 3. And if we look at the structure, it says we've got integer, character, integer. Okay. So L1 single square bracket 1 is a list, basically the first train car. Okay, so L1 it has basically 3 train cars, and this one gives you back the first train car. Double square bracket 1 gives you the contents of that first train car. Right? Here, if I use this, this says subset it down to the first train car, and then what's the second thing in the first? It doesn't exist, okay? Because you're referencing basically like there's only one item in L single square bracket 1, okay? It's a list of 1, and there's nothing there, okay? It's basically you've given a train with just 1 car, and then it says what's in the second car, and you're saying there's no second train, okay? Whereas here we use double square bracket 1, and so we are looking at the vector that's inside the train, okay? And then we can say what's the second element in the vector that's inside the train, okay? And that's going to be the element 2.
The double bracket will always return a vector?
Double bracket will always return what's inside.
Okay, so if it's a list, it'll return.
Yeah, I got that's the next example, okay? So the double bracket will give you what's inside the list object or what's inside that train car. And then the single bracket will always give you the train cars itself, give you the list. Okay, so here, L2 is a list of 3 things, okay? The first thing that I'm putting inside L2 is that list L1, okay? And then we've got just some vectors, 10, 20, 30, and D, E, F, G, H, whatever, okay? So it's a list of 3, and the first thing is a list of 3. And then we've got vectors. So L2 single square bracket 1, what is that? It's the first train. So, okay, let's go back here. Okay, so L2 is a train with 3 things, and inside the first train car is another train, L1, which has 3 things. Okay? Does that make sense? So we've got a train of 3, and inside the first train car, we've got another train with 3 things. Yes? Question in the back.
Will the double bracket one be used to subset this, or can it be applied to like other?
So the double bracket is used to subset, is primarily used to subset list and list structures. So that includes a data frame, because a data frame is built on top of a list. Okay? It can technically also be used to subset atomic vectors, and we'll talk about that later, but I would say its primary function is to subset lists. Okay? So L2 is a train. The first train car has a train inside. Okay? So when you do L2 single square bracket 1, it's going to return the first train car that has the train inside. Okay? So that's going to be a list of a list. Okay? It's a train inside a train. Okay? Which is what we have here. And that's why you've got the multiple square brackets, right? You got square bracket 1, double square bracket 1, double square bracket 1, double square bracket 1, double square bracket 2. Okay? So this says inside the first train car, which is the only train car, there is a train car. Okay? And inside that is a vector of 8. All right? And then inside this first train car, there is a train, and we're looking at the contents of that, the second car in the train within the train, and it's got the letters A, B, C, D. Okay, I know it's ridiculous, but this is how it works. Okay, so this is a list of a list inside a list, right? So we've got the train, the list of 3 inside the list of 1. Okay, over here, L2 double bracket 1 says, okay, I just want you to look inside that first car. Oh, and what do you see? Oh, it's a train. Okay, and now we can treat it that way. And so this is basically, now it's not a train inside a train, it's just a train. And then single square bracket 1 is just basically the first train car that has the elements 1 through 8. Okay? So this, what is the structure of this? It's still a list, right? And this doesn't exist because you're trying to reference something else here. If you want the vector that's in there, you have to use double square bracket 1, double square bracket 1, okay? And that will give you the vector that's inside the first train car within the first train car. I know it feels weird, but if you understand how all of this works, okay? Because if we want this vector, we have to say double square bracket 1 to get this first part, and then because that itself is a list, we have to use double square bracket 1 again to get this. Okay? And that's what we're doing here. Okay? And then if you want the second element within that vector, you can do that. Okay? And so you might see kind of these in the subsetting operations of lists, you're going to see like double square bracket, and then a single square bracket or something if you've got a list inside a list, which is a fairly common thing to happen in a lot of structures. So if you create a linear model, if you do LM in R, it's going to return a list of lists. Okay. All right. Is that okay? The subsetting of lists. We're good? Okay. Now let's talk about subsetting higher dimensional structures. We'll start off with the matrix. Okay, so the matrix is an atomic vector, right, with dimension attributes. Okay, so we can use this. We can subset this in the similar ways to subsetting an atomic vector, but now we have to specify the dimensions, right? So probably the most common method is to subset using multiple vectors, okay? But you can also subset using a single vector or subset with a matrix, okay? So here I've created a matrix, with the elements 1 through 9, and I've named the columns A, B, and C. All right, and so here, this always gets cut off here. Okay, so here is our matrix there, and this first thing will give us just the first 2 rows. All right, so you just say first 2 rows, comma, so you say I want the rows 1 and 2, and then comma blank. Blank subsetting means return back everything, right? So it's going to give all the columns in the first 2 rows. And then over here, we've got rows true, false, true, okay? And so it's going to give back the first and third rows, and the columns that it will return will be columns B and columns A. And so it gives us back B and A of the first and third rows. And then lastly here, it says 0, subsetting with a 0 says return none of the rows and return all but the second column, -2. And so we get this. It gives us the names of columns A and C, but there's no actual values there. Okay? It's an integer of length, an integer vector with 0 rows and 2 columns there. Okay? When you use single square brackets, it generally reduces to the lowest possible dimensionality. Okay? So if we ask, is matrix A a vector, it's going to say false. Okay? However, when you subset it to just the first row, this is no longer a vector. I mean, no longer a matrix. It actually becomes an atomic vector. It loses the dimension attribute. Okay? So if we ask, what are the dimensions of A, it's going to say it's got 3 rows, 3 columns. When you ask, what's the dimensions of A single square bracket 1, it's going to say this is just, there's no dimensions, right? It's a vector. Okay. Because matrices and arrays are basically vectors with just dimension attributes, then you can subset them as if they were a vector. So here I've created a character matrix of the letters of the alphabet just ending at Y. Okay, so I got A, B, C, D all the way up through Y. And I could just say I want the 8th and 9th letters, okay? And that will pull out the letter H and the letter I, okay? So we're not saying I want the 3rd row and 4th row and the 2nd column, okay? It's just saying treat it as if it were a single vector of 25 elements and give me the 8th and 9th elements. Oops. I have a typo there. It's not the 4th and 15th, 8th and 9th values. 8th and 9th values. Okay. If you treated the matrix as a single atomic vector of 25 elements. Okay. Over here, because you have rows and columns, you can also subset it using a matrix. Okay, so you can subset a matrix using a matrix with 2 columns. Okay, and each row will be the element that the coordinates of the element that you want. Okay, so here I have a matrix with 4 rows and 2 columns. Okay, and it says I want basically row 1, column 5. Okay, so row 1, column 5 is going to be U, and then here it says I want row 3, column 1. So we're basically giving it coordinates to say I want these elements within the matrix. Okay, row 2, column 3, and things like that. Okay, so we have the 2-dimensional structure, and then you can give it basically coordinates within the 2-dimensional structure and select out elements that way. Okay, and I would say this is probably the least common way to subset a matrix, but it is possible. Okay, it's possible to select individual elements out of the matrix by giving it the coordinates within this structure. Okay. All right, and so similarly, this got got cut off there. But so if we have a three-dimensional array, okay, so here I've got rows, columns, and sheets, then to specify coordinates, I need a matrix with 3 columns, right? So this would say I want the first row, second column, first sheet, okay? First row, second column, first sheet is 3. This part here says I want the second row, third column, second sheet, okay? Second row, third column, second sheet is 12, okay? So now that the array has 3 dimensions, okay, you need to give it a matrix of 3 dimensions, or of 3 columns to specify the coordinates that you want. Okay, so that's another way to subset a matrix or array. Okay, with data frames are 2-dimensional structures built out of lists, right? So we can subset a data frame kind of like the way we subset matrices as a 2-dimensional structure. We can also subset data frames the way we subset lists, okay? So, so this is what we have, all right? Here I've got a data frame, rows 1 through 4, 4 rows, X is 1 through 4, Y is 4, 3, 2, 1, and Z is the letters A, B, C, D, okay? And so here, when I say, give me back the rows where this is column Y, mod 2 is equal to 0. So that's going to give me back the rows where Y is even. And so it's going to give me back row 1 and row 3, because that's where the column Y is even. Okay, so it says, you know, this basically is a logical statement where it's going to go true, false, and it's going to return back the rows where it's true. So this is very handy when you've got a big data frame and you say, I want all the rows where state is equal to California or something like that, okay? And notice, because I'm using single square bracket here, subsetting the data frame using single square bracket is going to return what? A data frame, yeah. Okay, in here you can just specify the rows directly. I want the first and third rows. And here we're selecting the columns as if we were selecting a list. So here it says first and third rows, comma, okay? We've got a comma here to say I want these rows and all the columns. And over here I'm selecting it like a list using single square brackets because the data frame, the structure of a data frame is a list right now with list elements X, Y, and Z. And so here it just says I want element X and element Z. Yes?
Will the output be the same if you do comma, C, X, Z?
Yes, I think that's on the next slide here. Okay. So so here I didn't put the comma here. Okay, I just said I want the elements like a list, and then over here I put the comma, which basically says I want all the rows and the columns X and Z. Okay. And there is an important distinction, okay? If you do df single bracket X, single square bracket and the letter X, this remains a data frame, okay? However, if you use the comma and then the X, it simplifies to a vector. Okay, so this one will return a data frame of one variable. This one returns just a single vector. And this one, using the $, also returns just a single vector. Yeah, I should. Okay, I've got a few of these things. I don't know if we've got time to do all of them. Okay, what's going to happen if I do this? Okay, this is not going to work. I've got a single equal sign. Okay, if you want to test equality, you've got to use double equal sign, and then this will return all the rows in the data frame empty cars where the cylinder column is equal to 4. All right. Here I'm mixing negative with positive integers. -1:4 is actually the vector -1, 0, 1, 2, 3, 4. So if you don't want that, you either have to do negative parentheses 1:4 or something like that. Okay, I think. That's what I need to do here. Okay, and this will return all but the first 4 rows. Okay, what happens here? Yeah, there's no comma here. Okay, so what's going to happen? Empty cars $cylinder less than or equal to 5. If I run this, okay, empty cars $cylinder less than or equal to 5 returns back a true-false vector. Okay, and then it's kind of like trying to subset the columns of empty cars using a true-false vector. Okay, so it's you're providing this true-false vector to the columns of empty cars. So, so it says undefined columns are selected because you're saying like I want back, you know, whatever this 26th column or something, which doesn't exist, right? So you need to specify that you want these rows by putting in the comma. Okay. Equal to 4 or 6. This is not going to work, okay? Because what this is going to be what's going to happen here. This is going to be a true-false vector, okay? And then you have true, false, or 6, okay? And then so that's going to, the selection gets weird. So if you want to do a combination of true, false vectors, you need to use the OR operator with a logical vector and a logical vector, okay? All right, I'm going to just kind of skip through these and I'll let you look through that last slide, but because I think we're going to run out of time. But this is basically the same issue where here it's going to just select the columns 1 through 20 and not the rows 1 through 20. Okay. All right. We've got this issue of simplifying versus preserving, right? And so by default, R will simplify a lot of things, such as when you take a matrix and you select only one of the rows, it's going to simplify the matrix down to a vector. And if you want to preserve it, you have to use the option drop equals false, okay? Meaning drop unnecessary dimensions, okay? So generally, so you can think of it this way. I mean, for the list, we use the double square bracket can be thought of as a simplifying thing because you're pulling it out, where the single square bracket will preserve it as a list. But I would say the key part here to pay attention to is kind of the array, which applies to matrices. Okay, so when you do x single square bracket 1, it's going to pull the first row or the first column, and it will simplify it down to a vector, an atomic vector. Okay. If you want to preserve the matrix form of it, you say drop is equal to false. Okay. And here I just wrote capital F, but we know to write out false in all caps, right? Okay. Similar for data frames. If you want to simplify, extract out the kind of the column and turn it into a vector, you can do it this way. Or if you want to preserve that it's a data frame and you only just want one column out of the data frame, do it this way. Okay. If you pull out a single row of a data frame, it will always remain a data frame because the row will it's assuming different types. But it's when you're pulling out columns from a data frame, it will generally treat it as an atomic vector, okay, when you use like the $sign. And so here we have this, okay? So, well, the atomic vectors, you can use the double square bracket on atomic vectors, and what it does is it throws away names, okay? But it's not a big deal, okay. And then the list, we saw this, and then the factor will drop unnecessary levels if you put in drop equals true. That's kind of the only thing. All right, but here's kind of the key. So here I've got matrix A, which is basically a 2 by 2 matrix, 1, 2, 3, 4, okay? And if you pull out the first row and you say, so this, people are weirded out because I'm subsetting a matrix and I've got 2 columns, right? Or two commas. So it says first row, all columns with this optional parameter drop equals false. And so this preserves it as a matrix, a 1 by 2 matrix with just the with 1 row and 2 columns. Whereas if you do it kind of the normal way, it will simplify it to an atomic vector with the elements 1 and 3. All right. So this thing of drop equals true or false. Okay. Data frame, if you use single square bracket for 1, it will preserve it as a data frame with 1 column. And over here, double square bracket will just extract that column and simplify it down to an atomic vector. Question in the back. Why would you want to preserve it? So sometimes you want to do some matrix multiplication, okay? And so I don't know, let's say you want to just take the first row out of a matrix and you want to do some matrix multiplication. So you've got like a 1 by 10 matrix and you're going to multiply it by a 10 by 20 matrix or something, okay? And so your matrix dimensions have to match up. If you just extract the first row and then it simplifies it down to an atomic vector and then you try to multiply it by a matrix, it might throw a dimension mismatch error, okay? So sometimes a lot of times when you pull out 1 row, you just want to treat it as a vector. But sometimes you want to preserve the matrix nature of it if you're doing things like matrix multiplication and stuff like that. Similar for data frames, you might want to preserve the nature of the data frame for whatever reason. We don't generally do this, but because the rules of tidy data says don't do this. But in R, you can name the rows of your data frame, okay, which is what mtcars does. And so if you extract the column and it simplifies it, you're going to lose the names of those data frame rows. When you extract the column and you preserve it as the data frame, it's going to keep the data frame row names. Okay. The kind of Hadley Wickham's come along and kind of set up rules for tidy data, and he says don't name your data frame rows. So that's kind of a thing, but it's a thing. Okay. So yeah, if the output's a single column, it's going to return a vector instead of a data frame. Okay. The $sign is a simplification of using the double square bracket. Okay, and so it's going to extract out the thing, okay? And sometimes people, this is a question, is how do I pull out the column based on the name, but I want the name to be a variable? I don't know if you've ever wanted to do this, right? Like you wanted to pull out some column, but without having to actually specify the name of the column, like hard-coded in there, and you want to keep it as a variable. You can do that using double square bracket, right? So here I've got we're going to call the variable name is cylinder, and you can do mtcars double square bracket and reference the variable name, and it will pull out the cylinder column, okay? Whereas if you tried to do mtcars $ variable name, it's going to say that doesn't exist. There's no column named var inside there. Okay. The $ does do partial square matching, partial matching, which is if you're lazy, it can be handy. Okay. So if the column is named ABC, $A will actually work, whereas referencing it as the named A, that will not work. Okay.
But if there are multiple ones that start with A?
Yeah, then it'll get confused. Yeah. Okay. So this is, now we're getting into weird stuff, but it's important weird stuff. Okay. Because this is often the source of so many programming mistakes and errors and things that you run into. So these are not things you do intentionally. These are things that you do by accident. But by understanding what happens in these situations, you'll be able to debug your programs and stuff. Okay. So sometimes you'll have a vector, and then you will subset and reference something outside of the range of the vector. Okay, so X is a vector with 1, 2, 3, 4, and in your program, because I don't know, you're running a loop, you might, towards the end or beginning of the program or something, you might reference items that don't exist in this vector. Okay, and so if you reference the fifth object in an atomic vector, it will give you a missing value. Okay, it doesn't give you a null. Okay, it gives you a missing value. Right? So that's an important thing to, and if you subset using a missing value, it will always return a missing value. And if you subset using null, it will return a zero length vector. Let me see if there's anything else. Okay, and so here's kind of out of bounds means you're referencing like the fifth element inside a vector of length 4. Okay, if you so this is a little strange. Okay, so if you reference an out of bounds thing on a list, it's going to return a list with the null object. But if you use double square bracket and you reference this will throw an error. Okay, so here it says, you know, you've got a train of basically 4 things. You've got 4 trains, and you say, well, what's the 5th train car? Okay, and that's going to say, well, that's a non-existent train. Okay, it's a null train. Whereas over here we're asking what's inside the 5th car. That's going to throw an error. Okay, so this, sometimes you'll get errors when you're like working with lists and stuff, and it might say something about like, okay, let's see if I have, okay, so D is a list here, and so I can say D square bracket 3 will give me, you know, that thing. D double square bracket 4 gives me an error. It says subscript out of bounds, whereas D single square bracket 4 gives me, it says a null thing. It gives me back a list with a null. Okay. And things like that.
If you make a vector 1 through 4 comma null and try to output a subset of the fifth element, will that also return NA?
Well, you can't you can't put a null thing into a vector, right? So if I'm going to make vector b, which is 1, 2, 3, null 5, okay, b only has 4 things in it, okay? So this, and so if I subset and ask for the third element, it's going to say that. If I ask for the fourth element, it's going to give me 5, and if I ask for the fifth element, it says it's missing, okay? And b is this. If I insert NA here, are you guys able to see what I'm doing here? And we'll call this D. No, I shouldn't have called that D. Okay, so D is this. D is 1. D, the fourth element is NA. D, the fifth element is 5. And D, the sixth element is NA. Okay. Okay. You can do subsetting and assignment, and you can combine some of these things here. Let's see how I'm doing. Okay, I'm way behind here. There's just a few things. So you can combine subsetting with assignment, but these will give you errors and stuff. And let me just skip on ahead here. Okay. As far as lists go, you can kill entire columns or entire things in a list by assigning null to that named thing. So here, X is a list with elements A and B, and I can get rid of element B by assigning null to it. Okay. On the other hand, if you want the list object null inside B, you can do that by inserting list null. Okay, so this is, you're using the null object and getting rid of B itself, and over here we're using the single square bracket, and this is saying create a train with the null object inside. Okay, here are on the last few things, I've got important applications of subsetting. I think we're going to run out of time to cover all of this, but I don't want to spend a whole bunch of lecture time on Wednesday covering this. But they're just kind of some cool things. You can create lookup tables because you're allowed to reference the same index multiple times. Okay, so here by subsetting the lookup table using the values in X, we can actually create the name the things here, right? So you might want to do something like that. You can use random integers to subset, and it will shuffle up the rows. Okay, so that's a neat thing. And then there's the order function, which is also useful. And I recommend at least checking out the this section on ordering here. Okay, and then I'll leave all of these things in here, and you can kind of study them. But we'll run out of time to cover all of these things. Okay, we'll stop here. We'll see you guys on Wednesday.